Group design can be between subject design or within subject design. In between subject design, performances of separate groups are measured and comparisons are made between the groups. If we want to examine the treatment efficacy of using prompt on children with cleft palate, what should we do if we want to use between subject design? One group on the prompt and another group without the prompt. Within subject, prompt first, then traditional second. For within subject design, the performance of the same groups are compared in different conditions. With mixed subject design, both between subject and within subjects are used. For example, comparing different treatments between groups and outcomes before and after treatment and within the same group. A major consideration in the evaluation of the design of between subject experiments is the equivalence of the experimental and control groups. If the two groups of subjects exposed to two levels of the independent variable are different from each other in characteristics such as age, sex, intelligence, and prior experience, they may perform differently on the dependent variable because of these subject characteristic differences, rather than because they have been exposed to two different levels of the independent variable. The experimenter must ensure group equivalence in all respects except for the varied distribution of the independent variable within these groups. There are two techniques to achieve group equivalence: subject randomization, which is preferred when there is a large number of subjects, and subject matching, which is preferred when the n is small. With subject randomization, assign subjects to the experimental and control groups on a random basis. Therefore, each subject has an equal probability of being assigned to either group. Known and unknown extraneous variables are more likely to be balanced out if they are selected randomly. With small n's, this does not work well. Matching on all extraneous variables is considered relevant to the experiment. With overall matching, both groups have the same average and spread of each of the extraneous variables. Matching pairs is more effective than overall matching. Matching pairs is accomplished by selecting a subject for assignment to one group and then searching for another subject whose constellation of extraneous variables is essentially the same as for the first subject. Because no two people are exactly alike in all respects, matching is usually accomplished within certain limits of the extraneous variable. Within subject design, you have to be concerned about sequencing effects, including order effect and carryover effect. So, order effect, in which a general performance improvement or decrement may occur between the beginning and end of the experiment. For example, performance might improve towards the end of an experiment because of the practice in the task that they receive or because of familiarity with the experimental environment. However, subjects may show a decrease in performance in the latter part of an experiment because of fatigue. Carryover effect is also a threat to within subject design. A carryover effect is not a general performance change from the beginning to the end of an experiment, but rather the result of the influence of a specific treatment condition on the performance in the next condition. In other words, the result of one treatment condition may be carried over into the next condition. For example, in studies of temporary threshold shift induced by presentation of an intense noise, subjects must be given sufficient time to recover from the temporary threshold shift before experiencing a subsequent noise exposure. To reduce sequencing effect, we use sequence randomization and counterbalancing. Sequencing randomization is the presentation of the experimental treatment conditions to the subject in a random order. random distribution of the treatments in the time course of the experiment essentially washes out most of the sequencing effects in a within-subject design. Sometimes, however, the experimenter may wish to examine the nature of the sequencing effect that cannot be done with randomization. Counterbalancing is a technique that enables the experimenter to control and measure sequencing effects by arranging all possible sequences of treatment and then randomly assigning subjects to each sequence. Any difference in performance attributable to the sequencing of treatment conditions can be measured by examining the performances of subjects who participate in the different sequences.